You said another thing that broke my brain. You were talking about what the Big Bang is, and that we shouldn't think of the Big Bang as an explosion, but that before the Big Bang, time and space might not have existed.
Well, pretty much certainly not in the way we experience them, no. I mean, once again, no astronomer thinks the Big Bang came from nothing. The problem is, once again, we have no description of what that state of matter would be. None. The idea that everything we observe of in the universe could have once been at a subatomic scale. You'll notice I'm very careful about this. I talk about the observable universe. We have no idea how big the universe is. We don't know whether it's infinite or whether it has an end. But there's been only a certain amount of time that light has had to travel to us. That's not the whole universe. That's centered on us. That's an effect of we look in every direction in the sky. We can only look back as far as there's been time for light to actually travel to us. And you see some incredible things. I mean, one of the things that one of my friends has the Nobel Prize for is if you look so far away, the farthest away we can see now, we're looking back to a time about 400,000 years after the Big Bang. And this is something where we are actually able to see so far away. We're looking back to a time when the whole universe was hot and bright. It actually was glowing like the surface of the sun, the whole universe. The entire universe was so bright. It was like looking at the surface of the sun. And this this radiation has traveled a long time to get to us. It's now lost energy because it's traveling through the expanding universe. And as the universe expands, the wavelength of light gets stretched out by the expansion of space. This is what we call the microwave background radiation. So there's a microwave, very low energy signal. It comes from every direction on the sky. And it's coming from a distance so far away that the whole universe was as bright as the surface of the sun. And that's as far as we can see, because any farther away from that, the universe is opaque. Literally in every direction on the sky, you eventually look back to a time when the whole universe was so dense and bright, you can't see any farther.
Is this because of how we're capable of measuring? And is it possible that at one point in time, when we get better and better telescopes, that we can look past that?
Well, not with light. See, the universe actually does become opaque to light at that point.
Because it's too long ago.
It's basically, the universe is so bright itself. Yeah. I mean, so, you look in any direction on the sky, you look back to a time. The wonderful thing about the universe changing is we know this is true. The farther out we look with a telescope, the farther light has had to travel, the more time it takes to get to us. So the sun, we see, the light takes about 8 minutes to get from us to the sun. The nearest star, about 4 years. The nearest galaxy to us, about 2 million years. We can see so far away in space that the light took pretty much the age of the universe to get to us, about 400,000 years after the Big Bang. At that point, the universe becomes opaque to light. So there is a limit to how much we can observe with light, how much time there has been for light to actually get to us.
Is there a potential for being able to observe something other than light?
Absolutely. So your question is a really profound one. We don't know how big the universe is. When we talk about the universe, we mainly talk about the observable universe, everything we're able to see. So the question you just asked, can you see farther back, even if it's opaque to light? Yes. And this is something that, again, we talk about moments in your life where the universe changed, where you thought people did something you thought was impossible. And going all the way back to the mid-'90s, I was a postdoc at Caltech. And I wasn't working with this department, but people were starting to measure something called gravitational waves. And gravitational waves, again, I never thought they'd be able to actually detect these. The universe is constantly, I mean, every time we move, remember how I said time is different from the top of your head to the bottom of your feet. As I move, I create gravity. Gravity actually it goes out as a wave into the universe at the speed of light. Can you detect a wave of gravity?